I guess we will now proceed with the next presenter. Thanks again, Kim.
Brilliant. Thank you so much, Kim, for your talk. It was so interesting to see. So now we'll hand over to Elise. So Elise, if you'd like to share your materials, then we can get going with your presentation. Thank you.
Sorry, just give me a minute. Okay, great. Wait. Sorry. I have two screens and one is presenting on the other screen. I don't know why.
Don't worry about it. We're not in any rush.
Okay. Okay, well.
Thank you.
Yes, great. Okay. Hi, everyone. Thank you for coming today. I'm Elise and I'm a second year PhD student in the Neuroscience of Speech and Action Laboratory. Well, I don't know. Yes, and today I will be presenting something, an online healthy aging study we've conducted. So around the world, the population is aging rapidly, and in the UK in 2017, around 24% of the population was aged 60 years and older, and it's expected to increase to 31.5% in 2050. And with a rapidly aging population, dementia also becomes more prevalent. And both healthy aging and dementia are associated with worsening of cognitive functions or cognitive decline. And although some cognitive functions remain stable throughout our lives, such as vocabulary, other cognitive functions decline, such as attention and memory. And these includes difficulties retrieving words from our memory. These are called word-finding difficulties. So interestingly, a healthy lifestyle seems to decrease the risk of dementia, and this unhealthy lifestyle includes engaging in social activities and cognitive activities. So why should we investigate cognitive decline and lifestyle in healthy older adults? Well, investigating these things help us identify early neuropsychological markers of dementia, and these are indicators of either the risk for someone developing dementia or detecting dementia earlier on. Also, it can explain or help us understand why some people are better able to compensate for cognitive decline than others, and why some people develop dementia while others never do. So the cognitive reserve is a theory that was proposed to explain these differences, why someone is better able to compensate for cognitive decline than others. And this theory was proposed by Stern. According to the cognitive reserve theory, we build up some kind of cognitive reserve during our lifetime. And this cognitive reserve is built up through our lifetime experiences and our lifestyle. And this includes education, engaging in social activities such as meeting friends and family, engaging in physical activities, and engaging in cognitively stimulating activities such as playing music or reading a book. All these activities build up our cognitive reserve, which was then proposed to increase our cognitive and neuroflexibility. And with cognitive flexibility, we can think of cognitive strategies we can use to maintain our task performance. And with neuroflexibility, we can think about the networks in our brain. So our brain consists of different networks that allow different parts of our brain to communicate with each other. And cognitive reserve enables us to either strengthen these existing networks or recruit alternative networks to maintain task performance. On the slide here, we see a graph with the general idea of the cognitive reserve. Is that people with high cognitive reserve, so people who engage in these activities, they show a slower decline in, for example, memory, than people with a low cognitive reserve, so people who don't really engage in these activities, even though they would have the same underlying brain changes. Also, what this graph doesn't show, but what Stern also proposed, was that people with a high cognitive reserve experienced later onset dementia than people with low cognitive reserve, even though they would have the same underlying pathological brain changes. So how can we investigate word-finding difficulties? Well, there are several ways. One of the ways is to conduct a picture naming task. We can conduct this for both objects and actions, and during this task people have to name a picture as quickly as possible. For example, the picture of a bed, and then we say bed. We can look at reaction time and accuracy, and with what reaction time tells us is how effortful it is to retrieve a word from memory. So the slower the reaction time, the more effortful the retrieval was. And accuracy tells us whether someone actually achieved retrieving a word from memory or whether they failed. Previous research found that people experience more difficulties with picture naming with age, and this decline starts around 50 years onwards. We can also investigate word finding difficulties with a verbal fluency task, where people have to generate as many words within a certain time limit, such as 1 minute. There are several kinds of verbal fluency tasks. For example, we have the semantic or category fluency task, where someone has to name as many items belonging to a certain category, such as animals or fruits and vegetables. Then there's an action fluency task, where people have to name as many actions as possible. And this can be prompted by saying, for example, in 1 minute, name as many things people can do. And then finally, there's a letter fluency task, where people have to name as many words starting with a certain letter, such as the letter M. And then we can say mom, money, mummy, etc. Previous research found that a decline in verbal fluency starts around 40 years onwards. Interestingly, both tasks seems to be modulated by word frequency. That is, higher frequent words, those are words that are more common. These are easier retrievable from our memory than low frequent or uncommon words. For this study, we were interested in how cognitive reserve relates to word finding difficulties. And this was originally meant to be an in-person lab study, where we would also record EEG, so the brain waves, to look at the brain networks underlying. However, due to COVID, we decided to move the study online. And also because of the general COVID message, the stay-at-home message, we had to reduce our social interactions and contacts. And so we were interested in how the level of cognitive reserve changed due to COVID-19. We hypothesized that an increase in word finding difficulty, that with age, people experience more word finding difficulties, and that this is modulated by cognitive reserve. So for our study, we recruited in a total of 90 participants. We had 3 different age groups: a young adult group aged 18 to 30 years old, a middle-aged adult group aged 40 to 55 years old, and an older adult group aged 65 to 80 years old. And within each group, we recruited 30 participants. We decided on a 10-year age gap between groups because we wanted to make sure there was a difference between groups, and someone of 64 years old might not really differ from someone of 65 years old. Also, the numbers were based on power calculations, and all participants were right-handed monolingual speakers of British English, and they didn't have any current or history of language or speech disorders. We also pre-registered the study on aspredicted.org. So for our study design, we used both Qualtrics and Gorilla, and all participants started off on Qualtrics, where they filled in a cognitive reserve questionnaire. The cognitive reserve questionnaire had several parts. The first part was a general activity questionnaire, which contained questions about the social activities someone engaged in, such as meeting friends and family, cognitive activities someone engaged in, such as reading or playing a musical instrument, and the productive activities someone engaged in, and this you can think of gardening or woodwork, for example. And people were asked how often they participated in these activities in the past 3 months before COVID, and then the past 3 months, which would be during COVID. This was then scored on a scale from 0 to 3, which with a score 0, which meant never, I never participate in these activities, and a score of 3 every day. And then there was also a physical activity questionnaire, which asked how many minutes someone moved during a typical week. There was also a question about how long someone reclined during a typical week, and the score was subtracted from the total physical activity score. Then after the cognitive reserve questionnaire, people went on to the Gorilla website, where they did some behavioral tasks. Half of the participants started with the language tasks and half of the participants started with the control tasks. We included a control task for processing speed, working memory, and inhibition to investigate whether the word finding difficulties were more due to a general decline, a decline in general cognition, or whether it was actually language. The participants who started with the language task first started with the verbal fluency task because we wanted to avoid people being primed by the picture naming task or remembering pictures from that task. Also, the letter fluency task came always last because we wanted to avoid people using letters as a strategy in the semantic and action fluency task. For the picture naming task, we had both objects and action naming, and action naming came always last as it is perceived to be a bit more complicated or difficult, so we wanted to make sure that people were eased into the task before doing the action naming task. So we just finished data collection and we are still in the process of transcribing the audio data. So on the next slide, I will present you with some descriptives to give you a general idea about the data. So on this slide, we can see the total cognitive reserve score. The number of participants per group are not entirely 30, but that's because we're still in the pre-processing stage. The mean education of young adults was 14.9 years old, the mean education of middle-aged adults 16.2, and of older adults, the mean education was 18 years old. This included vocational training. And here we see some box plots, and on the y-axis we see the total CR score, the total cognitive reserve score. This was the score of the general activity questionnaire and the physical activity questionnaire together, and people could go below 0 because we subtracted the time reclining from the total score. The white dots represent the means, and the means are also presented above the box plot. And as we can see, the cognitive reserve score, the total cognitive reserve score between age groups seems roughly similar, and it doesn't seem to have changed that much before and during COVID. And if we zoom in further, here we see the different categories within the general activity questionnaire. The y-axis represents the cognitive reserve score. The score here is different from the previous slide because this was this was scored based on a scale of 0, never, to 3, every day, and that was then summed up together. Again, we can see the means as the dots here, and the means are also presented on top. We can see that older adults engage a bit more in cognitive activities than middle-aged and younger adults do. However, COVID didn't change this. Also, the pattern for productive activities didn't change due to COVID. However, for social activities, it seems that before COVID, the groups were roughly similar, but during COVID, the amount of social activities decreased quite a lot, especially for older adults. On the next slides, I will present some data about the language tasks. However, again, we're still in the process of the audio transcriptions. So yeah, I hope it will give you, oh, sorry. We also looked at the physical activity alone. We can see that the physical activity score on the y-axis, which is the minutes, total amount of minutes someone participates in physical activities during a typical week. The age groups don't seem to differ that much, and also COVID didn't seem to change that much in the amount someone moved during a typical week. Then we move on to the picture naming task. In this, for here, the data is for around 17 participants for the older adult group, and around 10 for the middle-aged and 10 for the younger adult group. Here on the left, we can see the mean reaction time per group and per task, and the standard deviation between brackets. On the y-axis, we can see the reaction time in milliseconds, and the error bars indicate the standard deviation, one standard deviation below and above the mean. You can see that the groups didn't really differ too much for both object naming and action naming, although older adults might be a bit slower than the middle-aged and younger adult, but further analysis should give more conclusive results about this. Then for the accuracy, we looked at, we also compared the age groups for each of the tasks. The y-axis, we can see the accuracy, and here on the left, we can see the mean accuracy and the standard deviation between brackets, all in percentages. We can see that all participants achieved high accuracy, above 90%, and older adults seem to be a bit less accurate than younger adults. We can also see that the standard deviation increases or is a bit higher for older adults, and this is typically found in the literature, that there's more variability within the older adult group compared to young and middle-aged adult groups. Also for the reaction time, this only included correct trials and also excludes any outliers, and outliers were defined as 2.5 standard deviations above and below the mean. For the verbal fluency task, as we can see, we don't have much data at all. This is because after audio transcription, we need to calculate the number of words correctly produced, and also we're interested in the average frequency of the words that were produced. For the semantic fluency task, on the y-axis here, we can see the total number of correctly produced words. These include these exclude any repetitions and any words that do not belong to any of these categories. We had 5 different categories, of which animals, fruits and vegetables, and vehicles were proposed to be more easy categories, and fluids and writing utensils as more complex categories. For the letter fluency task, we had 3 letters, the letter M, P, and S. And we can see there's some missing data, unfortunately. But I hope that this will give a general idea of how the data is broken down. Again, on the y-axis, we can see the number of correctly produced words, and the standard deviation is presented here in the error bar. For the action category fluency, we had 2 prompts, namely things people can do and things you can do to an egg. And for all these fluency tasks, we expect that younger adults produce more correctly produced words than older adults do. We also were interested in the average frequency of the words produced. So after audio transcription, for each single word, we look up the frequency of that word using the sublex frequency database, and then we average them per participants per category. So on the left-hand side, we can see the sublex frequency. And then again, for each of these categories, also for each of the letters and for each of the category. We expect that younger people produce lower frequency words than older people, or older people produce higher frequent or more common words than younger adults, because these more common words are easier retrievable from our memory. So what we saw was that the total cognitive reserve score, that's the physical activity score and the general activity score together, didn't really seem to differ between age groups, and also not due to COVID. However, if we zoomed in, the social activity cognitive reserve score seemed to have decreased for all age groups, and especially for older adults. For the picture naming task, we saw that the reaction times for both objects and action naming were roughly the same between the groups, although older adults might be a bit slower. And for the accuracy, older adults seemed also to be a bit less accurate than younger adults and middle-aged adults. For the verbal fluency task, there was not much data yet, but I hope you got an idea of how the data was broken down for this task. Once all the data is pre-processed and transcribed, we want to run linear mixed effects models for the different outcome variables for the language tasks, namely picture naming accuracy, picture naming reaction time, verbal fluency number of correctly produced words, verbal fluency average frequency of the produced words per category, and then we have the predictors age group, the cognitive reserve compound variable, the interaction between cognitive reserve and age group, and then the control measures I talked about before. For our next steps, we are going to run a secondary EEG analysis, where we want to look at how brain networks change with age and how this is related to verbal fluency. We will only have access to a semantic fluency task and a letter fluency task, and we will then compare between young adults and older adults. So thank you for listening. I really wanted to thank my supervisors and all the members of the lab who supported this project in different ways. And if you're interested in the references, you can scan the QR code over here. It also includes my email address and a link to the pre-registration form. Thank you, and yeah, feel free to ask any questions.
Thank you so much, Elise. That was such an interesting topic, particularly like your QR code at the end. So we have a couple of questions coming in, but if anyone else has any more questions, do just let us know. So the first question that came in here, Elise, is are any of the cognitive reserve factors dominant? For example, is education weighted more highly than anything else, or do they all weigh in the same?
So I didn't include weighings. I know that some studies do, but for the total cognitive reserve score here, I didn't include education. For this presentation, I only included the physical activity score and the general activity score, and this was weighted equally. I hope that answered the question.
Sorry, Megan, we cannot hear you well.
Sorry, is that better?
Yes.
Sorry. So is cognitive reserve something that builds up throughout life?
Yes, that is. Well, there's a discussion going on in the literature whether there is actually a certain time in our life that cognitive reserve can be built, or whether it can build throughout the life, like even at older age. And intervention studies where people would, for example, at older age, join education, 6 months education, did found some changes that, like, education at older age benefits cognition even. So yeah, there's still discussion going on.
Brilliant, perfect. And kind of related to that also, is work or study included in cognitive activities?
Yes, it is. Yes. So yes, it included studying, reading books, attending courses and workshops, but also, for example, listening and watching educating materials such as TED Talks, documentaries and quizzes.
Brilliant. So I think that kind of follows on and links to the answer of the question, why was education not included in CR score?
Well, the idea is to include it, but because of the preliminary analysis, I haven't included it yet. So for the end, I am including it because education is often used as measure in cognitive reserve, and often even as sole measure for cognitive reserve. Although personally, I believe cognitive reserve is bigger than only education. So yeah, I'm definitely intending to include that in the final score.
Definitely, perfect. And now we're just focusing a bit more on the statistics. So were you expecting bigger differences between groups for reaction time and accuracy data? And what does the lack of difference between groups mean for your study?
So I didn't expect major differences. I do expect a significant difference. However, I haven't, because this is just descriptives, I can't say there's actual difference there. But also, I only have data of 17 older adults for this presentation and 10 younger and 10 middle-aged adults. So that means that with a bigger group, we might actually find more differences. Yeah.
Yeah, thank you. And how many different LME models will you be running on this analysis?
So there will be 4 different outcome variables. So for each of these outcome variables, 1 model, and then we are planning on running it with the CR score before COVID and then during COVID, and then compare them.
Brilliant, thank you so much.
If there will be 8 models in total then.
Brilliant. So I think this is the last question we've got time for. I was particularly interested in the slight increase in cognitive activities with age group, which seems puzzling. Unless younger adults don't have as much time to read books or engage in some other form of activities. Have you found this? Have you observed this a lot? Do you have any sort of ideas as to why this may occur?
Well, if I speak from personal experience, I think younger adults might watch a lot of TV, which is not considered a cognitively stimulating activity if you watch series and stuff. Well, of course, older adults I think it's kind of a habit as well, as if you're older and you didn't have like access to that much TV as we do now, you would already like be more used to engaging in cognitive activities. So that's one thing. And also people who are retired might be and like have more time engaging in these kind of activities. Although of course younger adults do engage in activities through studies. Yeah.
Brilliant. Thank you so much for your time, Elise, and answering all the questions. It was a really, really interesting talk. So thank you. Thank you very much. Matthias, shall I hand over to you?
Yeah, so we will take a short break until 11 when Pablo will speak. So just grab a coffee or run to the bathroom and then we will be back very soon. Thank you again, Elise.
Yes.